Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. Our topic for today is the alkynes. In our today's lecture, we will study that how the structural formula for alkyne is drawn, and then we will also study that how these alkynes are prepared. What are alkynes? Alkynes are the hydrocarbons having at least one triple bond between the carbon atoms. The general formula for alkyne is CnH2n-2. Here, N represents the number of carbon atoms. So, let's learn that how the structural formula for alkynes is drawn. Ethine, which is also called as acetylene, is the simplest member of the alkyne family. In the ethine, two carbon atoms share 3 pairs of electrons to form triple bond. The electron cross dot structure for ethine is as follows. The carbon atom, as we know, forms 4 bonds and hydrogen atom forms 1 bond. In this diagram, the electrons of carbons are represented by cross and the electrons of hydrogens are represented by dot. Now, since carbon contains 4 electrons in its valence shell, so out of 4 electrons, carbon shares 3 electrons with another carbon atom to form a triple bond. So a triple bond is formed by the sharing of 3 electrons. 3 pair of electrons. This is one pair, this is the second pair, and this is the third pair. Now, if you look at this carbon atom, then 3 of its electrons are shared with another carbon atom. 1 electron is left unpaired. So, carbon will share this electron with the electron of hydrogen atom to form a single bond. So, in ethine, only 1 hydrogen atom is attached to each carbon atom. Carbon can form only 4 bonds. It cannot form 5 bonds. Now let's draw the structural formula for 1-butene. For drawing the structural formula for 1-butene, we will first see that the prefix used here is but. This prefix but means that this organic compound contains 4 carbon atoms. The suffix yne represents that it is an alkyne. And the number before butene represents the location of triple bond. So if you understand the names of the organic compounds, IUPAC names of the organic compounds, then you may easily draw the structural formula for that compound. Now, since the stem but is used here, so you will draw 4 carbon atoms in a row. After drawing 4 carbon atoms, let's number each carbon atom. After numbering the carbon atom, we will see that the triple bond is attached to which carbon? Here 1 is mentioned, so this means that the triple bond is attached to the carbon number 1. So we will draw a triple bond here. After drawing the triple bond, we will complete the valency of each carbon atom. Now, if you look at carbon 1, 3 bonds are drawn already. We will draw another bond in order to complete its octet, and hydrogen will be attached at the end of that bond. valency of carbon 1 is completed. If you look at carbon 2, then all the bonds of carbon have been formed. Carbon formed 4 bonds. So here carbon number 2 is forming 3 bonds, and at this position it is forming the 4th bond. So none of the hydrogen atom will be attached to the carbon number 2. Now look at carbon 3. 2 bonds are already drawn. We will draw 2 more bonds in order to complete its valency, and hydrogen atom will be attached at the end of each bond. If you look at carbon number 4, then only 1 bond is drawn for this carbon. So in order to complete its valency, we will draw 3 more bonds, and hydrogen atom will be attached at the end of each bond. So this is how the structural formula for 1-butyne is drawn. Let's draw the structural formula for 2-butyne. First, you will draw 4 carbon atoms in a row, because but means 4 carbon atom. Then you will number each carbon atom. Then see that what is the location of triple bond. It is 2. That is, triple bond is located to carbon number is attached with carbon number 2. You will draw triple bond here. After drawing triple bond, just complete the valency for the rest of the carbon atoms by drawing bonds. Now carbon number 2 and carbon number 3 valency is automatically completed. So we don't need to draw hydrogen atom along with carbon number 2 or carbon number 3. However, if you look at carbon 4, only 1 bond is drawn. So we need to draw 3 more bonds in order to complete its valency. So this is the structural formula for 2-butyne. Now let's discuss some general methods for the preparation of alkynes. Alkynes may be prepared by 2 methods. First is the dehydrohalogenation of vicinal dihalides, and second is the dehalogenation of tetrahalides. Now what are dihalides? Dihalides are the organic compound having 2 halogen atoms present in them. Di means 2. So if in any organic compound 2 halogen atoms are present within that organic compound, then that organic compound will be called as dihalides. These dihalides are of 2 types: geminal dihalides and vicinal dihalides. This is an example of the geminal dihalide. In this example, you may see here that the halide group, that is the bromide here, is attached to the same carbon atom. When 2 halogen atoms or when 2 halide groups, halo groups are attached to the same carbon atom, then that halide will be called as the geminal dibromide. Geminal dihalide is formed when 2 halogen atoms are bonded to the same carbon atoms. This is the general formula for the vicinal dichloride. Now vicinal dihalides are the organic compounds having halo group at the adjacent carbon atom. This is one chlorine atom, this is another chlorine atom, and each chlorine atom is attached to 2 different carbon atoms, but these different carbon atoms are present at the adjacent positions. So such kinds of halides will be called as vicinal dihalides. So vicinal dihalides are formed when 2 halogen atoms are bonded to the adjacent carbon atoms. So alkynes can be prepared by dehydrohalogenation of vicinal dihalides. Let's study the preparation. In this scheme, we will prepare ethyne from 1,2-dichloro-ethane. Now this is the vicinal dihalide. Why? because here the two chlorine atoms are attached to two different carbon atoms that are adjacent to each other. Other name of this compound is 1,2-dichloroethane. Now what happens that in the first step, this is the step 1, I will simplify this 1,2-dichloroethane by writing it as like this. Now in the first step, one hydrogen and one chlorine will be removed from this organic compound in the presence of alcoholic potassium hydroxide. Now when these two atoms will be removed, then there will be the introduction of double bond between these two carbon atoms, and it will result in the formation of chloroethene along with the formation of potassium chloride and water. You have read about this reaction in the previous lecture, which involves the formation of an alkenes. Now this is the first step. In the second step, we still have a chlorine atom attached in this organic compound. So what will happen? I am simplifying this organic compound like this. That hydrogen atom and the chlorine atom from this organic compound will be removed, and there will be the introduction of new bond between these two carbon atoms. So after the removal of hydrogen and chlorine from this organic compound, there would be the formation of triple bond between these two carbon atoms along with the formation of KCl and the water molecule. So in the first step, there is the formation of an alkene, and in the second step there is the formation of an alkyne, and in each step there is the elimination of HX, and this reaction is therefore called as dehydrohalogenation. So if you have one halo group in an organic compound, then it will result in the formation of an alkene with the process of dehydrohalogenation. However, if you have two halo group in an organic compound, then this reaction will end by forming alkynes, because these two halo groups will be removed in the form of HX. So this was one of the methods through which we can prepare alkynes. Which of the following alkyl halide will form alkyne on treatment with alcoholic KOH? If you look at this compound, then only one halo group is attached. If you look at this compound, then two halo groups are attached here. We just learned it that if one halo, we have an organic compound having one halo group, then that organic compound through this process will only produce alkene. However, if we have two halo group, then after the removal of one halo group, first it will form alkene, and then with the removal of second halo group, it will then form alkyne. So out of these two organic compounds, this compound will produce alkyne. Now this is the second method for the preparation of alkyne, that involves dehalogenation of tetrahalides. Tetrahalides are the organic compounds having four halo groups present in them, and these four halo groups must be present on the adjacent carbon atoms. Tetrahalides on treatment with zinc dust undergo dehalogenation to form alkynes. This zinc dust is the finely divided particles of the zinc and it is present in this form. This is the chemical reaction for the formation of alkynes from tetrahalides. This organic compound 1,1,2 tetrachloro-ethene is a tetrahalide because here 4 chlorine atoms are attached to the 2 adjacent carbon atoms. When it reacts with zinc, then this zinc in the first step reacts with 2 chlorine atom to form ZnCl2, and there will be the introduction of double bond between these 2 carbon atoms. So in the first step there will be the formation of alkene. This is the step 1. In the step 2, this compound 1,2-dichloroethene will react with zinc again. Now this zinc will react with these 2 chlorine atoms to form zinc chloride, and there will be the introduction of new bond between these 2 carbon atoms, resulting in the formation of an alkyne. So this is how the alkynes are synthesized by the dehalogenation of tetrahalides. Now let's do a review exercise question. Construct a scheme in order to convert ethene into ethyne. In today's lecture you read about the preparation of ethyne, and we read that ethyne may be prepared either by the dehydrohalogenation of vicinal dihalides or by the dehalogenation of tetrahalides. The structure for ethene is like this. So this means that we need to convert this ethene into vicinal dihalide or tetrahalide in order to convert it into an alkyne. So if we want to convert ethene into vicinal dihalide, we will react it with bromine water. When we will react with it with bromine water, then it will result in the formation of vicinal dihalide. Now this is a vicinal dihalide because here the 2 bromine atoms are attached to 2 different carbon atoms that are present at the adjacent positions. Now since you have formed the vicinal dihalides, then what you will do, that in the first step it will react with alcoholic potassium hydroxide to form this compound. Then in the second step it will again react with alcoholic potassium hydroxide to form triple bond. Now from alkene you have synthesized an alkyne, that is ethyne. So what we did, we first converted ethene into vicinal dihalide, and then we did the dehydrohalogenation of this vicinal dihalide to form this ethyne. So this was all for today. In our next lecture, we will study about the properties of the alkynes. Thank you for being with me.